The topic is structure and types of ovules. Firstly, ovule. The ovule is a component of the female reproductive systems of seed plants. It is where female reproductive parts are produced and maintained. Ovule is also known as the megasporangium in flowering plants. The ovules develop and its ball begins to thicken to transform into seeds. The ovule is found inside the gynoecium, a part of the flower present in angiosperms of flowering plants. Next, structure of the ovules, component of the ovule. The ovule is composed of the integuments firstly, forming the outermost layer. The nucellus, the female gametophyte, known as the embryo sac in angiosperms found in the core. Next, nucellus. The most significant component of the ovule is the nucellus. It contains nutritive tissues and the embryonic sac, and in some flowering plants, female gametophyte. Gamete producing sex component essential for sexual reproduction are located in these portions of ovules. It is also known as the megagametophyte or the embryonic sac. Next is the integuments. A layer of production surrounds the ovule called integument. Once the ovule has undergone fertilization, the integuments forms into a seed coat. Gymnosperms has usually one integument and named as the unitegmic, whereas the angiosperms typically possesses two integuments and named as the bitegmic. Next is the ovule is the integument megasporangium. It contains the stalk and the body. Stalk has the funicle. One end of the funicle is carrying an attachment where the placenta, and the other end is carrying an attachment with the body of it. The point where funicle and the body attached is cilium. Many times funicle get fused with the body of the ovule. And the body ovule has two ends, and they are the basal end and other end is the upper and called as the microfilar end. The main body of the ovule has a cover of one or two envelope that we called as the integuments. This leaf and opening at the top portions of the ovule named as the microfile. The integuments encloses a huge parenchymatous tissues that we called as the nucellus. And next, the types of the ovules. The ovules are characteristic by the considerable diversity in shapes, degrees of development and structures. Mirabel 1929 for the first time classified ovules under the four groups: orthotrophous, anatrophous, campylotropous and the amphitrophous. But later on another two types added, making the ovules altogether as the six: orthotrophous or heterotrophous, anatrophous, hemianatrophous or hemitrophous, campylotropous, amphitrophous and the cisinotrophous. And firstly, orthotrophous ovule. It is the heterotrophous or straight, where the microfile, chalaza and the funiculus are all in the same line. For example, cycas and members of the Polygonaceae and the Piperaceae families. Anatrophous ovule, in 80% there is a very common type. In this ovule, the funicle is long, body is inverted through 180 degree. As a result, microfile come close to the funicle. Most common, almost monocots and dicots like the members of Astraceae and the Solanaceae. Next is the hemianatrophous or hemitrophous ovule. The body of the ovule is inverted through 90 degree. As the funicle come close to the lies at the right angle to the nucellus, microfile and chalaza lies in the same plane. Members of primitive family like Ranunculus or Ranunculaceae. Next is the campylotropous. When the body of the ovule is not inverted but it appears like the horso, the microfile and the chalaza do not lie on the same plane. The nucellus and the embryo sac remain straight. Members of the family like Brassicaceae and the Fabaceae. And next is the amphitrophous. It is almost similar to the campylotropous, but the nucellus or embryo sac is bent like horseshoe. Next is the cisinotrophous ovule. It is the very rare in occurrence, where the body of the ovule is bent through 360 degree, so that it take a complete turn. Chalaza and the nucellus are on the same plane. That's it. Thank you.